Welcome to another interesting mathematics class. My name is AK Omoji, your mathematics friend and tutor. Today we shall be talking about quadratic graphs under the topic Quadratic Equations Part 6. By the end of the class, you should be able to do the following. 1. You should be able to draw quadratic equation graphs. Also, you should be able to read and obtain roots from a quadratic graph. Before we go on to learn how to plot quadratic graphs, I'd first of all like us to understand what a graph is. So, what do you understand a graph to be? A graph is simply a pictorial representation of organized data or values. In order to plot quadratic graphs, we normally need to track the relationship between two or more variables, which could be x and y. Also, we need to get a table of values and as well make use of the x and y coordinates. Graphs generally are referred to as charts, and they could be of different types. When I say different, there are so many of them. It could be a pie chart, it could be a line graph, it could be a bar chart, and many others. So don't get confused, they are all the same. They are referred to as graph or charts. In scientific works, it's either you use a table or a graph to represent information. Both of them actually can represent exactly the same information, but one is more detailed, and the graph is that one that is more detailed. As you can see on the board, we have a graph and as well a table of values. The table of values has the same information that the graph holds, but we cannot easily see from the table of values where the minimum value is. Neither can we see the maximum value. But by looking at the graph, you can easily see the minimum value and as well the maximum value. Like I said earlier, from the table, we really cannot easily track where the minimum value is. But as you see on our graph, here is our minimum value. It is so easy that you can just look at it and see it here. As well, you can see the highest value, which is 3,64. This simply means it occurs when x is 3 and y is 64. Now that we know the difference between a table and a graph, let us see how the graph is actually plotted or drawn. To draw a quadratic graph, we first of all will need a graph sheet as shown here. Sometimes we'll have to divide our graph sheet into 4 quadrants, and to do that, we'll have to draw a horizontal line and then a vertical line. We call the horizontal line the x-axis or the abscissa, and we call the vertical line the y-axis or the ordinates. From the x and y, we'll generate the scales. But before that, we need to indicate where our graph begins, which we call the origin. And that is indicated here as 0, 0. The first 0 stands for the x-axis, the second 0 stands for the y-axis. So 0, 0. Next, we'll have to give our graph a title. In this case, we'll just give it the title graph of y versus x. And then we'll need to get a scale on the x-axis, which is generated from the values on the x-axis. Furthermore, we'll get a scale on the y-axis, which is also generated from the values on the y-axis. After doing that, we'll need to start thinking of how to plot values on this graph. So let's take for instance that we have a value of x as -4 and then 3 as y. When we trace these two lines, wherever they meet, we would put a cross and a circle there. We will repeat this for other points that may be given to us based on the table of values. And so we'll have different points later on. Well, this point will be indicated as x, y, but we don't write x, y. We'll actually write the values as -4, 3, right? Next will be other values like this. So we'll just trace different other values depending on the table of values. And then when we are done tracing the whole values, we'll get a curve like this. Remember, this curve is not just drawn with free hands, though you can do it with free hands, but it is advisable you draw it with a French curve so that it will be very neat. However, you can use your broom or you can use a thread or other things that are flexible. However, like I said, it is recommended you use a French curve. After this graph is drawn and we now have this curve, next will be how do we read and obtain roots from this graph. It's important for you to know that the roots are the points where this curve cuts the x-axis. So from this graph, our roots will be -3, 0, which means at this point x is -3, and as well 5, 0, which means at this point x is 5. Well, you can find other things from this graph if you wish to. Things like the vertex, which is the steepest point on this graph. Well, from our graph, the vertex is -0.5, -3. Remember, -0.5 stands for the x value, while -3 stands for the y value. This curve itself is the same as the equation that formed this quadratic graph. So we can simply write it like this. For my own example, the equation that formed this curve is y equal to x squared minus 2x minus 15. So let's see an example of how these steps are put into place. Let's assume that we have a table of values given to us now, and the table of values is shown on the board. Remember, we said we need a graph sheet, right? So this is our graph sheet. Oftentimes, we'll have to divide this graph into 4 quadrants, as I said earlier. We also have to give our graph a title after we've labeled the x and the y axis. So our scale on x would be 1 cm represents 1 unit because of the values you can see on the board. While on the y-axis, our scale will be 1 cm to represent 3 units because of the values you can see on the board. So next thing to do is to start plotting this graph based on the values given to us from the table of values. So we say when x is -3, y is 11. You could see that we trace from -3 and then from 11 as well. Where they meet, we put a cross and a circle. We do that also for -2 and 5. Where they meet, we also put a circle. Do that for -1 and 0. Next, we'll repeat that for 0 and -3. We continue that way until we get to x equal to 3 and y equal to 0, which are the last values on our table. And then next, we draw a curve that touches all these points. Please take note, there are also times the curve may not touch all the points, but you take maximum number of points. So we draw a curve that touches all the points or maximum number of points. In our case, the curve will look like this. Remember, I said this curve should be made using a French curve. When we draw this curve, next thing to find are the points where this curve touches the x-axis. Those points are the points we call the roots, right? So let's find the roots now. You can see these points circled in red. These are the roots, which are -1 and 0, which actually says that the first root occurred when x is equal to -1, and the next root occurred when x is equal to 3. Remember, that curve itself represents the equation that formed the quadratic graph. Now let's go on to see an example of how to plot or draw a quadratic graph. Let's assume that we are given the equation 6x squared plus 4x minus 2 equal to 0, where x ranges from -3 to 3, and we are also asked to solve it using the quadratic graph. How do we go about this? The first thing we need to start doing is to think of how to generate table of values. So let's start with our first step. We have to rewrite the equation from the form ax squared plus bx plus c equal to 0 to the form y equal to ax squared plus bx plus c, which in this case is 6x squared plus 4x minus 2 equal to 0 to the form y equal to 6x squared plus 4x minus 2, where y equal to f of x. This simply means y is a function of x, or y depends on x. Please take note, when we say the dependent and independent, we are simply referring to which one depends on the other. When we say one axis depends on the other, it means that the value of the independent axis determines the value of the dependent axis. For instance, normally y would depend on x, and while plotting our graph, we will normally say the independent axis will be on this axis, and then the dependent will be on this axis. So the horizontal will be the independent and the vertical will be the dependent. Now that we are done with our step 1, let's try our step 2. Our next step is to create a table with the headings x, x squared, ax squared, bx, c, and y. Since the value of a is equal to 6, the value of b is equal to 4, and the value of c is equal to -2, we can rewrite the headings as x, x squared. We now have 6x squared instead of this. And then we now have 4x squared instead of bx. And then we can write -2 in place of c. Our step 3 is to fill the values of x into the table. The values of x could be given or assumed. In this case, actually, the values were given, but take note, it is good practice to ensure that the ranges of x is from negative to positive and is also symmetric. What do I mean? For instance, we could take x values to range from -3 to 3, -4 to 4, -5 to 5. In that way, it will be symmetric. However, this is only conventional. It is not a must to be this way. You can still take values that are not truly symmetric. In our current case, x ranges from -3 to 3, and that is what we will use. Our step 3 is to fill the values of x into the table and obtain the other values. How do we do that? Let's start by filling the values of x. X ranges from -3 to 3. To fill the x column, we have -2, -1, 0, 1, 2, and 3. Now we go back to the next column, which is the x squared column, and then we fill in this column as well as follows. -3 is the value of x here. So what we need to do is to say -3 squared. When we do that, we'll get 9 here. Now let's go back to the next column, which is the 6x squared column. To do that, we now say 6 times the value of x squared, which is 9. When we do that, 6 times 9 would give us 54. The next column now is the 4x column. To do this part, we are only saying 4 times whatever value we have for x, and in this case, it is -3. So we now have 4 times -3, which is -12. The next column is the -2 column. Well, in this column, all we need to do is write down -2. And for y, we would evaluate the value in the next step. So we'll continue the same way for the other values of x. Now let's see how to evaluate for y. Now our step 4 is to evaluate for the values of y, which is y equal to 6x squared plus 4x minus 2. Remember, these values on the left hand side were gotten in our step 3. So now let's see how to evaluate this. All we need to do is to write down the values here. 54 minus 12 minus 2 would give us what? 40. The next one is 24 minus 8 minus 2, and that will give us 14. In the same way, we fill in the other ones as now that we have the values of y evaluated, our step 5 is to plot the graph of y versus x. To plot the graph, we make use of the values of x and y as given in the table below. Please note, this table is referred to as table of values. Now to plot our graph, we'd have to look at our table of values, which is given here. And then from our table of values, we'll be able to generate the scales on x and y axis. The scale on x axis is 1 cm to represent 1 unit. The reason for that is because from here to here is 1 cm. You can measure that on your graph sheet and it will give you 1 cm. And then you can see the value written here as 1. That's why we are saying 1 cm on your graph sheet represents 1 unit on the x axis. Also on the y axis, you can see that from here to here is 10. That means 1 cm represents 10 units on the y axis. The next thing to find is the value of each of these small boxes, which we call square boxes. If you look at the y axis, you see that, like I said earlier, 1 cm represents 10 units. That means for each 1 cm on the y axis, we have 5 boxes. But each 1 cm is equivalent to 10 units. So the value of each square box on the y axis is equal to 10 divided by the number of square boxes, which is 5, and that will give us 2. Now let's do the same on the x axis. Note that for the x axis, 1 cm represents 1 unit. That means for each 1 cm, there are also 5 boxes, and each 1 cm represents 1 unit. So for the x axis, each square box is equal to 1 over 5, and that is equal to 0.2. Now that we have the scale on the x and y axis, we have the title as y versus x, and we have the values of each of the square boxes. Now let's proceed to plotting the graph proper. Let's start by tracing the values as shown in our table of values. Let's trace the first values here. When x is minus 3, y is equal to 40, and we trace upward to where it intersects 40. Now let's trace from 40 and let it intersect this line that we traced now. As you can see, they both intersected here. So we draw a cross and then make a small circle. Please take note that these circles are not just drawn from wherever you like. If the 2 points meet somewhere here, take note of this. If the 2 points meet here, this circle can only touch this box, the 4 boxes that close it. Do not draw it bigger than these 4 boxes. The next value to be traced is minus 2 and 14. So let's trace this pair of values now. When x is minus 2, y is 14. Okay, let's start tracing from minus 2 and trace upwards. We have a problem now. How do we find 14? Because there's no 14 on our graph. This is where we now put to work what we learned earlier, that each of these square boxes on y-axis is 2. So here will be 12 and here will be 14. So we trace from that 14 now. And then add our cross and circle it. The third to be traced is minus 1 and 0. So when x is minus 1, y is 0. Let's trace that. Well, this is simple. X is just minus 1 and y is 0. So it appears here. Let's also trace to find out when x is 0, what the value of y is. From the table of values, we know that when x is 0, y is minus 2. Remember, each of these squares is 2. So here on the y-axis is minus 2. Let us trace the x. It will all intersect here. Next is 1 and 8. When x is 1, y is 8. Let's trace from x to y now. X is 1, y is 8. Remember, each of the square boxes is 2. So here is 2, 4, 6, 8. Let's trace here till we intersect. Draw your cross and then circle it. Next is 2 and 30. When x is 2, y is 30. Let's also trace from 2 up to 30. Where they intersect, add your cross and then circle it. Lastly, when x is 3, y is 64. Let's trace that. Trace from 3 up to 64. Since this is 60, here is 62, and here is 64. So we trace from here. Where they intersect, make your cross and then circle it. We have all the points. Now, the next thing to do is to draw a curve. To draw this curve, you can use either a broom, a trade, or you can use a French curve. Well, it is recommended that you use a French curve because it will give you a smoother curve. So let's make our curve. For now, I'll make my curve using freehand. Now we have our graph completed and we have the curve. What we should do next will be to find the roots from this graph, and we'll see how to do that later. But before we go on, just note that the root is simply where this curve cuts the x-axis. Wherever that curve cuts the x-axis gives us our roots. This is the same graph we just plotted not long ago. You see it looks neater, right? And better here. Well, that's because here we actually did it with a computer. So you can actually plot your graph with a computer. But when you finish plotting your graph, I know you must have been expecting us to join the lines straight like this, right? Well, that's not the way we join them. These lines are not joined straight, but we make a curve as shown earlier. So this is how our graph looks. And like I said, wherever this curve cuts the x-axis gives us our roots. So our roots from this graph are -1 and 0.3. Having solved that example, let's now summarize the things we've learned so far. First, we learned that quadratic graphs show the relationship between x and y on a graph. Also, we learned that the roots are the points at which the curve cuts the abscissa or x-axis. Next, we learned that the vertex is the lowest or the highest point of the curve on the ordinate or y-axis. Furthermore, we learned that the curve in the graph is a quadratic equation. Going on, we learned that larger values of a compress the curve inwards. Smaller values of a expand the curve outwards. And negative values of a flip the curve upside down. In all this, a is always the coefficient of x squared. Now it's test time. So let's try out some simple exercises. Question number 1. What are the roots of the graph in figure 1? Option A says the roots are -1.0 and 1.2. Option B is -2.4 and 2.3. Option C is -2.2 and 3.2. Option D is -1.5 and 3.0. The answer is C. That is because this curve cuts the x-axis at -2.2 and 3.2. Question 2. Which of these quadratic equations produced this graph? Option A is y equal to x squared minus x minus 2. Option B, y is equal to x squared minus 5x minus 6. Option C, y is equal to 3x squared plus x minus 2. Option D, y is equal to x squared plus 2x minus 3. The answer is B, y equal to x squared minus 5x minus 6. That's because this curve cuts the graph at x equal to minus 1 and x equal to 6. By the time you expand them, x plus 1 and x minus 6 by expansion will give you x squared minus 5x minus 6. Thank you for your time. I am sure you can now plot quadratic graphs. Till we meet again. Bye-bye.